in 6.3. Now we get into all the other stuff, all of the sine and cosine and trig stuff. Let's take a look at page 415 because it has some problems for us. And if we do the review problems at this point, we won't go too far wrong in preparing for the test. So let's just talk about some basics of sine and cosine functions. First question, what is the period of cosine?
2 pi.
Period is 2 pi. And what is a period?
Like the distance that makes it one complete. Where it goes from one point and then to the exact same point on the y-axis.
So we get the same value again.
Yeah.
You can think of it, in this case, as peak-to-peak value. Is cosine of 0, 0, or is cosine of 0, 1?
Cosine is 0, 1.
Yeah, cosine of 0 is 1. And by the way, because people are having trouble remembering that, that is my new picture on ngrade. When you go on ngrade, it says cosine of 0 is 1 and sine of 0 is 0. So every time you look at your homework, it's right there until it burns itself into your memory. So cosine starts up here and it comes down, goes up. So Emerson, what's the distance from here to here? Just in a straight line this way?
2 pi.
It's 2 pi. That's what a period is. A period is how long it takes for the sine wave to repeat the pattern again. And what are the maximums and minimum values for cosine?
Maximum is 1, minimum is -1.
Maximum is 1, the minimum is -1. It's because cosine and sine are both bounded that we have a special name for a number put out in front. What is a number put out in front called?
Amplitude.
That's called the amplitude. If we're going to make that A, we should probably make that A also, shouldn't we? Yeah, the A out in front is amplitude. So our basic formula that we have for sine and cosine waves is A cosine K theta plus C. Now this is the way the book writes it, and I've mentioned why I don't like this. How would I prefer that you write it? I would prefer that you factor this out. I would prefer that you do it A cosine K times theta plus C over K. Then this is your amplitude. What is this? Or what does this affect?
Period.
This affects the period. What is this?
Phase shift.
That's your phase shift. This is completely analogous to what happens with a parabola. When we have y equals x squared, if we change x to x plus 2, we say y equals quantity x plus 2 squared. What happens to the parabola? It shifts 2 to the left. It shifts 2 to the left. If it's positive, if it's x plus 2, it shifts in the negative direction. If it's x minus 2, it would be 2 in the positive direction. The same exact thing happens with sine and cosine waves. So if you factor the k out, I know the book says, oh, leave it like that. No. If you factor the k out, when you're given a phase shift for a problem, you can just plunk the phase shift down there. Then you can figure out what k is. You can re-multiply it out to get this. There's much less chance of making a mistake. And when it's in this factored form, it's easy to tell what's what. It's not easy to tell what's what here. People look at this and say, oh, c is the phase shift. No, c is not the phase shift. C divided by k is the phase shift. So it's much better, I think, to write it this way. Okay, so sine and cosine have a period of 2 pi. Yep, let's just see about graphing something here for a minute. Let's start out easy. What if I say 2 cosine of 2 theta minus pi over 4? Okay, how is this going to change this graph right here?
It's going to shift it to the right, pi over 4.
Okay, first of all, it's going to take this sine wave and it's going to pull it over to the right this way by pi over 4 units. So if it goes this way, that means this axis is, over here now. And that's a little far over. It's right there. Good.
It's going to be taller.
Okay, it's going to be taller. How's it going to get taller?
Well, by
This one? This
Gotta go to
one?
two.
In fact, let's do this. Let's make this a different number so we don't confuse our numbers when we graph. Let's do that.
It's gonna get taller by 2.
It's gonna be taller. This is gonna be 2. The peak here will be 2, and the peak here will be negative 2. Now, what's the peak to peak distance?
Now it's gonna be 4.
The peak to peak distance is 4, but what's the amplitude? Okay, if you are given peak to peak information, what do you need to do to convert the peak to amplitude?
Cut in half.
You got to cut it in half. It's a very common mistake not to do that. The other thing is if I give you an amplitude, if I just give you a problem, I say write the equation of the cosine function which has an amplitude of 2 and a phase shift of blah, 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 and go on. What do you have to put out in front of the amplitude? If I say the amplitude is 2, if I just give that to you, you got to put a plus or minus sign, right? Because you don't know whether the wave goes down first or whether the wave goes up first.
Right. Or absolute value. That's right.
No. Okay. If I ask you what's the amplitude, what you do is you take whatever. If I had a negative 2 here, if I said what's the absolute value, what's the amplitude, you put an absolute value sign on that and just tell me 2.
Yeah.
But if I tell you that the amplitude is 2, you can't put an absolute value sign on it because it'll always come up positive. It only gives you one of the 2 wave possibilities.
Okay.
So in that case, you would have to say plus or minus. Don't forget that. That's a very common mistake on the exam. All right, so back to this. So I'm up 2 and down 2. We've phase shifted it. That's nice. What does this number do?
Stretch it out. Makes it bump. Or makes it free.
Squishes it.
Oh, squish it.
Good. It's squishy. Okay, if I have a 3 here, what's my formula for period?
Oh.
2 pi divided by k.
Yeah, period is 2 pi divided by k, and in this case, k is 3. So it makes one complete revolution in
2 pi over 3.
Yes, it does. Oh, did I move the axis the wrong way?
No.
No, because it's at pi over 4. Nope, I moved it the wrong way. We're good. Yeah, because at pi over 4, this should be at its maximum peak. Yeah, that's right. That's correct. So the question is, how big is it from here to here?
It would be
2 pi over 3.
Are you sure?
Oh, okay. Let me see. Did I pull that the wrong way?
You did.
Oh, let's see. We moved the whole graph to the right, pi over 4.
We moved it right.
So if it's at 0, if this is at 0, let's ignore the 3 for a second. So at pi over 4, that should be our maximum peak. No, because when this is pi over 4, when that's at pi over 4, this whole thing is 0. And that's when it hits its peak, and this is pi over 4.
Okay.
So no, it's correct. But it's good to check because it's real easy. It's real easy to move this to the right or left when you mean to move it the other way. So check it. You know, I don't mind people saying that's wrong. I make mistakes. We should check these things. So that's in the right place. So if we know that this peak is at pi over 4, and we know that our period is 2 pi over 3, what's this peak at?
2 pi plus pi over 4, so that would be 9 pi over 4.
This is pi over 4 plus,
Or 2 pi over
2 pi over 3.
Okay.
So we got to use our fractions. Got to come up with a common denominator. This will be 3 pi over 12.
Can't you cross multiply?
Yes, you could go like that. You could go like that plus that over that. Sure.
So it would be then
3 pi over 12 plus 8 pi over 12. 11 pi over 12. Now the other nice thing is you have a lovely TI calculator that you can use on the exam. So once you graph something, you can always check it by putting it in the TI. I think these problems are harder than graphing all the rest of the trig functions. I think sine and cosine waves are much harder to graph than tangent or secant. And the reason is tangent, cotangent, secant, and cosecant all have what?
They're asymptotes.
They got vertical asymptotes. All you have to do to make the graphing of a sine or a cosecant or tangent wave easy is just find the first asymptote and know what the period is. Once you find that first asymptote, you know that all of the other asymptotes are going to be spaced out along that period, and you know what a tangent graph looks like, or you know what a secant graph looks like. Well, what does tangent look like? Just doodle it for me in the air. Yeah, like that. Right. What does a secant graph look like? Just doodle it in the air. Looks like a U. One U up, one U down. One U up, one U down. So on those, I don't even bother to worry about phase shift. And what I do with those is I say, all right, where's an asymptote? So I intentionally look for the discontinuity. If it's a tangent graph, I say, when does tangent go to infinity? Well, tangent is sine over cosine. So when is cosine 0? Cosine is 0 at 90 degrees. So at 90 degrees, I'm going to get an asymptote. So I just take this part, whatever this is here, and I say equals 90 degrees, or equals pi over 2. Once I have that first asymptote, I calculate the period, and I just put down a bunch of asymptotes, draw the graph in between, done. So I think, I know that we are more familiar with sine and cosine in terms of doing problems, but as far as graphing, sine, tangent, cotangent, secant, cosecant is a lot easier. Let's erase this over here. Let's do some cosecant stuff.